Hey all, Nicholas DeMario of SterlingKisses.com here, and today we're looking at a bit of a challenge I had to figure out for a new piece. This pendant is going to be set with a large gemstone, and the trick is that these leaves are made to overlap the stone. Now, there are a few ways to go about this, but I decided that the best way would be to cast the pendant in two parts, the main body and the leaves separately. And the idea is to rivet the leaves onto the pendant by these little prongs. The prongs will pass through these holes made in the main body of the pendant. First, the gemstone goes in, then the leaves go on top, then the metal prong sticking through the back will be squished out, making a small rivet head that should hold everything in place. Here we are back in the real world with our 3D printed parts. The gemstone fits perfectly, maybe a little too perfectly. At least for now it does, but this might be a problem later on. We'll get back to that. And here's one side of the leaves that will be riveted on. I'd love to test fit it, but the sprue is in the way and I don't want to risk snapping one of the posts. These pieces were printed in Resinworks 3D Easycast Brown material, which I have a full review on. There'll be a link at the end of the video. The pendant's going to be cast in 14 karat yellow gold, and since I don't cast gold too often, I'm going to make the most of this session and cast these skull dice in the same flask. The pieces are sprued up as normal, paying careful attention to how metal will flow into the cavities that are left behind once they're burnt out. Even though I'm using vacuum-assisted casting, which should pull the molten metal throughout the cavity, I still try to orient them in a way that helps the metal to flow naturally. I find it helps to think of how water would want to flow, traveling downhill with gravity. I've covered the investing process in other videos, so let's skip ahead to the good part. Those leaves and posts are pretty thin, so I'm casting at a high flask temperature of 1100 degrees Fahrenheit. This high temperature should keep the metal from freezing at any thin areas before completely filling. Now that might be too high of a temperature for the larger, heavier skull dice. The reason being is that if the metal cools too slowly, it can shrink, causing porosity. But let's see how they came out. Looks great to me. Every surface looks nice and clean. Even the small pre-made holes for the rivets came out. The sprue tree is pickled out and the pieces are cut free with a jeweler's saw. These skull dice were just going to be a little side feature for the video, but they came out so nice that I think I'll give them their own video and show you the rest of the process and what I have planned for them. The holes in the pendant are drilled out a bit to help the posts fit through them more easily. A test fit is made, and one side fits a little more snug than the other, but I'm very happy with how this is going. Now that I know the leaves will fit, let's check the stone. Yep, I knew this was going to be a little problem. The pendant is a hair too small for it. Between the shrinking or expanding that the resin prints go through with curing, and the actual shrinkage that takes place from casting, it can be a little tricky to get a perfect measurement from CAD to finished piece. It's usually only about a 1% difference, so I try to compensate for this by printing the piece that much larger. After burring out a small amount of metal, the gemstone fits perfectly. I make sure the facets of the gemstone are aligned nicely with the pendant and pre-polish before the next step. This was a very satisfying moment here, and anyone who's ever built anything knows this moment when all the work and all the pieces come together. It's one of those moments where you can just take a break and admire your work. The leaves fit perfectly over the stone, holding it tightly in place. Here we see the post sticking through the main body of the pendant. I trim them down to leave just enough metal to make a small rivet head out of them. The actual head of the rivet is made by flattening over the metal on top of these posts. This is done with the aid of an electric hammer. I support the front of the piece with the bench pin, making sure I'm supporting the metal and not putting pressure on the stone. I then go over the back of the posts, basically squishing the metal outward. I work in a sort of circular motion, applying firm pressure to help spread the metal out. This was pretty hard to film close up, so here I just lightly demonstrate the technique. And here you can see the difference between the squished post on the right and the unworked post on the left. You really don't need that much metal to work with. I actually trimmed down the posts back even further than what you saw me cutting earlier. Now that I'm done making the rivet heads, I give them a cleaner appearance using a small beading tool. Finally, the piece is buffed on a polishing wheel, then placed in an ultrasonic to clean. This was a fun piece to make, and I hope you enjoyed watching the process. I also hope you come back to find out how these dice turned out, as well as some other neat projects I have in mind. Once again, I'm Nicholas DeMario of SterlingKisses.com. Thanks for watching.